Okay, so hi everyone. Let's get started with the new webinar this week. It's about outperforming the equally weighted S&P 500 index. So this is again in the context of the UBS 2020 Quant Hackathon, and we are dealing with the first competition, which is the S&P 500 competition, and you need to outperform it. So just a few words before we begin. So I'm going to use a support notebook for this webinar, and this will be published in public notebooks. There will also be a Q&A session at the end of the presentation, and we will endeavor to answer all questions. Obviously, it's going to be difficult to answer everyone, so the best way, if we don't answer your questions, is to go on the website, go on the forum, as you've been very active with doing, and then ask your questions, and we'll be prompt to answer. Let's get started then. So I'm going to start with a bit of operational descriptions around the competition, because as you know, we are going to start distributing points at the end of this week, so on Sunday 27th, and you will have to submit your solution before that date, before the 27th, at 11:59 p.m. New York time. So this is the details in order to be able to collect points. So that's why I wanted to start with guiding you to submitting your strategy. It's very important that you submit your notebook before the time stamp that is the cutoff, and it is also very important that you submit a notebook that works. So we're going to see that in a few minutes. Let's go through. You'll see there will be two leaderboards type. So one leaderboard type is the individual competition leaderboard, and that's going to be specific to each competition. So for the S&P 500 competition, you will have your scores, and that will be displayed on there. So the scores, just for a reminder, is your information ratio, your diversification ranking, and your raw business ranking. So we'll make an average of that in order to see who ranks first. So this is what the leaderboard will show, and then you will have a second type of leaderboard, and that's the leaderboard for the hackathon itself. And what is it going to show? It's going to show you the points you collected. So I invite you to go on the UBS Hackathon page to understand the rules and how points are distributed. But basically, depending on your ranking every week, the first few people will get points depending on that ranking, and then we'll aggregate this, and we will get a global hackathon ranking, basically. So you have two types of leaderboard, and the thing to note is that the competition leaderboard will be updated as we go. So whenever we have a submission and we process it, we will update this leaderboard. But the global hackathon leaderboard, where the points are, so the important one, is only going to be updated once a week. I've put also in there that your submission has to be validated by us. That's very important, and we will cover that over the whole webinar. But the important point is that your solution must be working, must be replicable, and must be a strategy that could go live if need be. So that's one of the conditions for you to appear on the leaderboard. So how do we submit? Well, that's I'm going to describe it, but first, you know the dashboard. In the research section here, you have knowledge base and wiki. Everything is documented so that you can submit. It's here. That's the link, dashboard, and then there is a page in the knowledge base called submissions. So if I just show you that, and I'm here on my dashboard, and I go to the knowledge base here, I will have submit a strategy or model. And everything is explained in there. I'll invite you to read all this, and especially my point about reproducibility. So we need to be able to reproduce your solution. If it's just a static solution that we cannot reproduce, then there is not much point in having your solution. Just read all these. It's very important. You can see that we have distinguished between what the solution should look like for the machine learning competition and what the solution should look like for the S&P competition. And then we describe all the steps to submit, which I can show you directly now. So the first step to submit is to go to your notebooks. So notebooks, just a reminder, is here. So when you open notebooks, you end up in there. And usually you're going to have your file system. So I have a dense file system, but you will have a smaller file system. And then you can locate the notebooks that you want to submit. Here I am in my Python folder, notebook folder, and I have a notebook that I want to submit, which is called UBS Webinar. Just opening it here. Before you submit it, make sure that it runs from A to Z, that the whole notebook can run. So just give it a try. Obviously, if you have a model that takes a while to train, or a strategy that takes a while to run, just run it for a shorter period of time. But it needs to be replicable. So at the end of the day, we will make it run on our servers. So it is important that it does run. And then once you make sure that the solution works, then you submit it. And here you want to submit for competition. That's a new submission. I haven't submitted that before, but if you had, then you choose update previous submission. Here I'm doing new submission. So my notebook name is like UBS Hackathon submission, and then I am going to participate in the UBS equity competition, and my team here. As most of you will have custom payouts, meaning your strategy will be hosted within a function, and we'll go through that later in the webinar. But you will need to submit that payout at the same time as you submit your notebook. This means that your function must be in the QLib. QLib is this tool here, where you can publish functions, and you would have put it in your team. Here you would have put it in my team. I haven't have anything here, but that's where you would submit save your payout so that you can submit it. And then once you have done that, when you've listed it here, you will see your function appear here. So just for the sake of argument, I'm just going to change team, and I will have a lot of functions here that I can choose from now. So I'm just not going to do that. I'm just going to keep it with my team, and then I do that just to get through. Then you read all the terms and conditions for your submission in the Alphien, and then you can submit. Once you have submitted, the strategy goes towards us, and then we start our reviewing process. So just for you to be able to track what has been submitted or not, you can go to your dashboard, and here in my notebooks you will have that UBS Hackathon submission that was just submitted in Python. I've submitted it for my team, and it's pending review. So what does it mean? It means that someone from our quant team is going to take the submission and try to replicate it and see if it runs. If there is a problem for some reason, then the member of our team will send you a feedback, send you a message to tell you what's working or what's not working, and if there is something to modify. Obviously, if nothing works, then we will reject your submission. But if there are minor changes to be done, then we will send you back some messages. The messages will appear here. You will be able to interact with us. If we just take a look at what it could look like, it is at the end here. You will be able to click on the button, and you will see a comment from us, and you can start a chat with the member of our quant team in order to determine what you need to do to make it a valid submission. So please monitor this space, my notebooks, in your dashboard. So this is pretty much how you submit. And now that we know the operational way, let's dig into making some doing some payouts. So as I said at the end of the previous webinar, and it was just an introduction about payouts and how to structure them, it is very important that the payout is correctly structured so that the strategy becomes systematic. What do we mean by systematic? We mean that it is going to run in the future on new data, basically. So there are a few things to keep in mind. First of all, I wanted to highlight that there is a benchmark. You know, when you read the rules, you saw that one of the criteria for your ranking is the information ratio, and the information ratio is a ratio that uses a benchmark. Okay, so we will compare your results versus a benchmark, and the benchmark for this competition is the equally weighted S&P 500 index. It's not very complicated to understand what it means. It's just an equal weight between all S&P members. Okay, that's different from the regular S&P, which is market cap weighted. So this is important to understand, and as I say here, you need to know what the benchmark is, because at the end of the day you need to beat it, so you need to understand how it's constructed, and you also need to understand how it behaves, and what are its strengths and weaknesses, so that you can do better. That's important to analyze. So our first step here is going to be to replicate an equal weight for just to get a feel about what it's doing, and then we'll move on to a more custom payout that is different from equal weight. I also wanted to highlight another important point that I've talked about briefly in the last video, and it was about making sure that when you do that, when you create your strategy, when you replicate your benchmark, then you use information only in the past, not in the future, and that you make sure that the information you are using expands as you go along. We will talk about this in the second part of the coding exercise we're going to show, but that's important. We'll come back to that. Let's start with going to the Jupyter Lab and see how we can replicate the benchmark first. So I have prepared this notebook here. As usual, I'm going to load the library. Let me just get the font a bit better, a bit bigger, so that it's readable. I'm also going to follow this. Here we go. The library, I'm going to run everything again so that we're sure that it's fresh. So as usual, just import the quantitative library so that you can work with it. For convenience reason, I am going to use the star import after that in order to have a more convenient way to call functions. So the loading is coming through. Let's just wait for it to finish. All right. Now I'm just importing the data package for convenience. As I said, anything in the data package will now, because I'm importing star, I will get all the functions directly callable, which is quite nice. Just as a reminder, if you want to know what's in the data package, you go in the QLib, and here it's all organized by packages, and the data package is all these functions here. So I can now call them directly from my environment. I wanted to just highlight a few things that we have improved over the past few days, especially to help you to make inclusion matrices. So to determine if a stock or series of stock is part of the S&P, because that's one of the requirements. We've improved the get ticker function to get you the appropriate list. This function here, get GIC as description, is just describing the meaning of each sector. If you don't know, what a function does, either you go to the QLib to check the documentation. So now I can go there, get GIC as description, you can view it. And from there, you will have the documentation. Here it says that it provides a map for the global industry classification standard. Okay. So we are going to just see in the first few steps of this notebook how to separate data and check data by sector. If you want directly from the lab whilst you're coding, you can also have this sort of nice looking docstring, which helps you know how to call the function and what are the arguments that are provided. So here, this is my ticks. I'm not sure I've run it. Here it is. So I see there are a few levels: sector, industry group, industry, and sub-industries. What I'm going to do is just look at a sector called financials. So the sector is here; it's the highest level. And I'm just going to take all the financials. So I'm just going to run this and get the list of all financial stocks. That's it. That's financials here. But you see there are many industry groups within financials, banks that have different financials, for example, but you have other ones. And then you have also industry, which is even more granular. And you can dig down like this. Now that we have the view, let's say, like the data frame view of financials, I'm just going to, I'm not too sure what's happening here. Let me just make sure that that I just overwrite the changes. That should be good. And now that we have the list of financials, I'm just going to take the names, basically, of the industry that I am interested in here, all this list of industries. Reason I do that is because we'll see in a minute the ticker function allows you to use the industry argument. So if I just take all the industry, I just take them unique values and put them into a list, and then I call get ticker S&P with the industry being all the lists that constitutes financials, and then I get the ticker from that. So again, if you don't know how get tickers work, you can see that get tickers here receives either tickers or industry code or industry. Here I'm using industry, and if you scroll down, you can see that the industry here is going to subset the ticker data frame by an industry. So here I've given it a list of industries, so all the industries within financials are going to be subset, and then I take the tickers, the unique tickers, and I put it into a list. So the reason why I'm doing all that is to have one dimension, financials, just one sector. And then I wanted to have a bit of exploration of all the data that is within that sector. To do that, we are going to use an object that we have designed. It's called data features. Obviously, I haven't run this, so this is not going to work. But data features, basically, again, if you don't know what it is and how it works, I suggest that you do look into the signature and the docstring. The way I am popping that up from the lab is when you are inside the function call, basically, you do Shift Tab here, and you can directly read the doc string as you are coding or typing. Obviously, here the process to get that would be just to look for data features in here, and you would have the same documentation appearing here, and you can look at the wiki. You have a version in R and a version in Python. So here I am willing to see the version in Python, here in Python, and see how it works. Okay, so everything is described in there. So basically, what does it do? It's an object to create a data feature. So basically, the data feature object contains all relevant information to retrieve and process data. So I'm going to use that basically to say I want all the stickers that are in the financial sector, basically, and I want all fields, OHLC and BB Live. I haven't put volumes, but you could put volumes if you want. And then there is a new one here, a method called load. Again, what does it do? Here, loads data feature data. Okay, so basically here I'm creating this object, data features, that is going to have all these stickers and all these fields, and here I'm loading the data. So once I have that, basically my object, let me just show you, is a data feature object that has a parameter called PXS, and basically this parameter is the prices for all these stickers and all these fields. And yeah, here we go. So you see you have all prices at all dates for these stickers and these fields. And as I've run it already, I've done load, you have already, by doing this, called all data that you wanted from the database. So everything is stored inside the DTF. So now you can start manipulating all this data. For example, we have a plot method in the data feature. If I go there, method, I have a plot method which allows you to apply filters on the data and plot them. So if you just do that, I'm saying I want to plot, and the tickers here is allowing me to apply a filter to my data features, and I want just the insurance industry. So as I said, we have grouped all industries within the financial sector, and here I'm looking at one in particular, which is insurance. I'm getting all the tickers in the insurance industry, and then I'm passing that in to the tickers argument within the plot method, and that is directly subsetting, so it's giving me a view, like a reduced view of the relevant things I wanted. And I've also reduced my universe just to BB Live. Again, remember here I had open price, high price, low price, close price, BB Live for each ticker. Here I'm just saying no, I want the BB Live. And I can directly plot all this into one single chart. By default, if you look into the documentation of plot here, you will see that there is an argument called rebase, and by default it's true. What does rebase do? Whether to rebase the time series to its first valid value. Here I'm rebasing all the time series to the first valid value they have. So that's what it's doing. Why am I showing you all this? Is because now you can basically use this data feature class, or this data feature object, in order to load all the data you need within it, and then decide to use just a selected subset of this whole data. I'm going to show you that in a payout. So this is my payout. I'm going to replicate the equally weighted S&P 500, and here you can see that my first argument is actually a data features object. it doesn't say it, but this is how I have constructed the payout function. So in here, I am going to pass it on a feature, and I've put also an industry argument. And then what it's going to do is going to get an inclusion matrix. How do we do that? We call the getTickers SNP function, and apparently that's returning an inclusion matrix. And then from that inclusion matrix, I'm just going to get the weights. Obviously, that's the equal weight S&P 500, so I just need to divide all included tickers by the number of tickers that are in the index. So that's quite interesting, because now with these 2-3 lines of code, I can have my benchmark. I can replicate the benchmark. So let's just take a deeper look at what this here does really, because it looks interesting that it can return an inclusion matrix. So if we indeed look at this and give it the tickers that are, remember we have already the variable called tickers, and we use this argument as price equal true. We'll probably modify the name of that argument because it's a bit confusing, but we will return a matrix basically of included stocks. So let's take a look at it. That is going basically to tell us in time. So on the rows it's going to be it's going to be dates, and in columns it's going to be all tickers. Basically, it's going to tell us if it's included in the S&P or not. So this is what I showed in the previous webinar, and that one of the tasks was for you to create that. We have decided to package it into that getTickers function so that it's easier to create that filter, that inclusion filter in your payout. So now you can directly use that. And you get the matrix back. Remember, you need to put that argument here in order to have this this thing. Obviously, here I've done it for the whole tickers here, but you could decide to use here you have more filters if you want, so you can choose to set an industry. Here I'm just going to try and see what the insurance industry is, and that is going to give back the inclusion matrix only for this industry basically. Okay, so that's a nice way to get that matrix quite quickly, and that will allow you to filter out tickers within your payout. I'm just going to get rid of that. So the first line here is just basically give me the matrix of what tickers are included in the S&P throughout the backtest basically, and then well, if it's a 1, then just basically divide by the number of members of the S&P at that date. So that's pretty much it. You don't need to do much more in order to get what you want. So I'm just going to rerun ticker because originally we had subsetted it. Now we are going to use all tickers. Again, I'm using data feature because it's a nice way to have everything packaged within only one object. And then I'm going to use the portfolio pipeline to backtest it. Again, let me just run that. Again, you can construct a portfolio with all the tickers. Here, I'm just taking the whole tickers across the whole universe. And then you apply the payout, but I'm just going to explain this line because it's very important. You apply the payout, which is equal weight S&P 500 select payout. This is this one. And then I'm passing in an argument here, df. df is here. I've created my data features with the whole universe. And what it means is that basically within portfolio here, or within your payout function, which is quite the same, you can pass in a features object as a first argument. Because as we saw, and let's just double check that, df.pixs, I need to basically load that. So loading just request all data within the universe of tickers that are included in data features, and then I will just display what it looks like. Here it's taking probably 30 seconds because the whole universe, the whole tickers are included. Here we go. I have the end. So all tickers here, and when I load, I create this prices basically argument, which is storing all the time series of all tickers. So that's when I do that, everything is in the object. I don't need to call it anymore, and you can manipulate directly from the object what you have to do. By default, see, I haven't called here. I haven't passed on fields in data feature. See, the fields, I left it at default, and the default field is the BB Live prices, so the adjusted prices here. So this is why I am able to basically use these data features in the payout, is because the data feature allows me to have this series of prices through it. So basically that works. That's compliant with the fact that a payout should start, the first argument should be the data that you're going to use to compute your allocations. And this is pretty much it for this pipeline. Let's get rid of that, and we can then backtest the portfolio and see the results. We are going to see, so this, some people have noticed there is this line here. It's not a blocking line, meaning it's just for your information that a few of the weights within your payout are not executable because there is a non-trading day. So what we do is just we push them forward to make them executable. But this is just for informational, it's not blocking. So it's not a problem if you have a message saying that some days were closed, because we are pushing your weights one day forward so that we can actually trade them. Here you see the metrics of your portfolio with the portfolio total return, and as there are so many assets in the portfolio, we reduce these graphs to only the top 5 and bottom 5 assets by Sharpe ratio within your selection. As you see, at first here, that's an interesting graph with the weights of the portfolio. At first, you could see that these blue weights were included, but then they stopped being included. So that drop out from your payout. Same here with the gray, they were included and then they stopped being included. So it means that our inclusion matrix work. So that's pretty good news. All right, so that's pretty basic, let's say, but it's important to understand the metrics and what you need to beat. 9%, you need to beat that in order to have a strategy that works. And then from that, you can start looking at adding more complexity to your payout. Just notice here in the payout that I have put industry. So what I could do here is when I build my portfolio here, I could do industry equal insurance. Okay. And then rerun all this in order to get an equal weight, but only across that industry. Basically, that should give you basically a way to check if there were industries that perform better than others. Obviously there are, and if you need to overweight some industries versus other industries, or it's going to allow you to have what's called sub indices or sectorial indices of the S&P, and to try playing with that, start playing with that. Where am I? Yeah. So let's just run the back test for the insurance industry, and then we move on to having a more customized or custom payout. Okay, so here the industry looks like it's not good. It's not a good result, because it has a very large drawdown and it returns less annually than if you diversify with all sectors. So you can play with that and try to check what happens to sector, and start incorporating this information into your payout. So let's move on quickly to having a custom payout, and here you can see that it's much more complex than the one before. Okay, much more lines. So we need to go step by step and check what it does. But basically, what we can see is that it's a momentum payout I've created here, and again, it's using a features object as a first argument, and this is when it becomes quite important and quite interesting. Here, just for the sake of argument, I'm going to recreate a new data features that have all tickers. Remember, this TKR was all tickers available throughout the period, and I am going to load all the series, all the time series that are available for tickers. Okay, and that's open, high, low, close, and BB Live. So if I do that, I will end up having all tickers and all available fields. But what's more interesting is that I can directly pass everything inside my payout here. Okay, and then let's dig into the payout. Here, the first block, what is that? I extract time series that I want, basically. And this is really the key point here we wanted to show about this data feature, is that here you can subset from the data feature whatever field or ticker you want. This is what we showed earlier on with the insurance sector. You can subset something. So here, I didn't load it, but I'm going to load it just to show you. So here my data features is empty. I'm just going to load. I'm going to load all prices, and then I'm going to do a subset. So what a subset does is, I'm just going to look at the documentation, which is not going to pop up because I'm running a sale. If I look at subset, it creates a subset of the data included in the data feature. Okay, so that's just the broad description of that method. If I scroll down, load, subset, here it is, my method subset. It takes the data feature object, and it's basically turned it into a new data feature object with only the series you want. Okay, what can we pass it on? Tickers, fields, mainly. So let's start with this. You can see that there is also a zoom and a split argument, and as data feature, which is whether to return the subset as a new data feature object or as a data frame. Okay, so if this is false, then it's going to return a data frame. If it's true, it's going to return a data features object. So okay, from that we are going to be able to take this data feature. It's taking some time to load all data, but once you have loaded all data, so the whole universe basically, then you don't need to do it anymore, and you can manipulate series directly from the object. This is exactly what we do here. We take the whole universe, and then we use only what we need, the subset. But the important point, and we are going to go down to that, is that by passing the data feature as an argument, then you don't have to create many times a new data feature. It's already there, and the data is already there, so you can basically manipulate all series without having to call data over and over again. So it's going to make you save time. Here I have my data object, and we said that there is a subset method, that is taking tickers, field, or anything. So I'm just going to do field equal open price. Let's just check before that the data feature is actually what we want, so that it has all prices. Yeah, it has all prices: open price, high price, low price, close price, BB live, for all tickers. Okay, that's a big data frame. Okay, 300 something columns, and here I'm just taking the first 5. But if we look at the whole shape, it's 2,500 rows as well. So it's a big matrix. So that's exactly it. Now we can subset it, and if I do this, then I have a new data feature object. See, it was quite quick to subset. So you have a new data feature object. What does it have? You have all the tickers, and for only the field that I've selected, open price. That's good. Does it work? Obviously, it's going to work with if you change it for high price, then you have a high price. So see, now it's pretty quick to start getting only the data you want. If you want, I don't know, tickers, the first few equities, let's say, and then this, let's take Apple as well. Apple. Okay, so I'm just going to have high price for that, so it's pretty quick. Now you have only the data you need. But remember that all data is still in DF, so there is no more database calls, and I can manipulate things quite quickly now. So let's just get rid of that. So going back to this, my feature that I'm going to feed in, I'm going to subset it only by BB live, because I'm going to compute a momentum, and my momentum will be quite simple. It's just going to be the rate of change over 250 days. Okay, so is it a positive momentum? So do we have a positive return over the past year, or do we have a negative return over the past year? And because I'm going to use the subset, you saw that it was pretty quick. So this is going to create my momentum indicator here. I'm taking, I'm going to name the columns the same as all the tickers that I have available. And then again, I'm using this getTickers function to get the inclusion matrix. Obviously, I want the inclusion matrix of all the tickers that are in my feature, because this is what I'm feeding in. And then what we're going to do is this time around, for this particular payout, we're just going to try and rebalance every month. Okay, so this is something you can also do with data feature. Let me show you that. It has a change frequency parameter. So if we go and recreate here our data feature 1 object, and only take one of the fields here. Let's say I want the low price, and that's the fields that I want. So I have my new df1, which having prices for only the subsetted part. Okay, that's correct. And now what I can do with that is basically change the frequency, and I want my frequency to be monthly. That's giving me an end of month basically data point. Okay, you can do other ones if you want weekly on a Thursday, so it's going to take every Thursday of every week and just resample that to that date. Okay, so that's pretty handy. Obviously, if you don't know how it works, again, you can check the documentation, and here you just need a frec or custom frec, and it's going to change the data features, data frequency. Okay, so you need data feature object in order to be able to do that. If you don't know which frequencies are allowed, you just read the doc string, and it says it's listed by this function. So if I just do that, I can see that what's available is, let me just get rid of that message. Okay, so you see that the available frequencies that you can use are these, and here you have custom monthly, for example. Let's just take that and see what it does. Hope. Where am I? Okay. Here we go, custom monthly, but I need to, if I'm using custom monthly, I need to tell it which custom frequency I want to use. So I want to do it every other month. Obviously, again, look at the doc string to know that there is a custom frec signature, and that custom frec is the number of periods for the custom frequency. It only works when frec is custom daily or custom monthly. Okay, so let's do that. And here I can see that basically every 2 months I have an index. So that's going to help us in our payouts. Delete that here, and the payout is indeed going to use monthly frequency, because here I'm just changing the frequency to monthly, and then I'm taking the index of that new matrix in order to define some rebalancing dates, and then I'm just looping through the dates. So here what I'm going to do is basically I have my rebalancing date. So at each rebalancing date, I am going to check if the stocks were in the S&P at that date, and also I am going to check if the momentum here, what was the momentum at that date. Okay, so if the momentum is high, I'm going to decide it's a good momentum, it's a stock that I want to buy, and I'm going to select the top momentum as ranked by sort value here. So all the momentum at that date is going to be sorted by descending order. So what selection I'm going to do is defined here by select 50. I'm going to select the 50 here, the top 50 momentum, and then I'm taking the name of the stocks, and I am putting a weight of 1/50 to them. Here you see there is a try catch, which is basically some dates don't have any momentum values, so I need to skip that, and I'll skip that here as well. And then we'll run the payout. So to test your payout, just take a look. My payout is called momentum S&P select. It's expecting a data feature object, which we have defined here. So you can just call that function and test it to see what it returns. and our expectation is that it returns a matrix of weights, okay, and those weights will be basically 2% for the selected stocks and 0 for the rest. Okay, so from there we can again build a portfolio and see how I pass the data feature here. So basically the data feature is defined outside from the portfolio. So each time you are going to run that, so even if you change the parameters or anything, you're not reloading the data. The data is here. It's in this object. That's very important. So if you go and run that, then it's going to evaluate your payout, and then we'll backtest it. But here I have kept just the default parameter. If we go back up, the momentum is over 250 days, and we are allocating to 50 stocks. Okay. So this is not great. We're not doing better than the benchmark here. But now we can start and play with our portfolio without too much of a hassle, because all our data is outside, so we don't have to call them again and again. And you can just decide to change parameters. So here, for the sake of argument, I'm just going to create another portfolio, which I'm going to call portfolio 3. And here I'm going to change my momentum parameter. So just as a reminder, when I declare my payout, I do payout, and then the first argument is always the data argument, so either data frame, or now you could see that you can feed in a data feature, and then you pass in the rest of the arguments if there are no defaults. So here my momentum was over 250 days backwards, so I'm just going to change it to something like 3 months. 3 months is 62 days, 62 working days, weekdays, and you can start playing with that again and again, so that you're saving time by using the data feature. There is also something quite important in the payout itself. I invite you to read it more in detail. We're going to publish that, but here you can see my first thing is to extract the time series of interest, but I could as well put field wanted with this here, refactor that, and now you have a new payout where you could very easily, directly from this line here, you could now change easily field wanted equal, I don't know, if you want to change and test what it does with open price, then you can change it directly here, and you wouldn't have to do anything else. So that's quite important to have a modular and a flexible payout, so that you can test many things. Here we have changed the momentum to 3 months backwards, and see what happens. It's slightly improving our performance, but it's still below the benchmark. So I'll let you explore a bit more and see what you can do to fine-tune and tweak the strategy to make it better. My main message here is try to optimize the way you use the data, and try to call as little as possible get history data, because otherwise it's going to take you some time. Just try to create a data feature object, and then from the data feature object just push it into your payout, and then you're going to keep your RAM under control, and you're going to be able to test much more versions of your payout more quickly. That's pretty much it for this notebook. obviously, if you have remarks about it, please let us know. I will publish it by the end of today on the public notebook part, so it's going to be appearing here in public notebooks, so you can go and check it out. Let's go back to our presentation, and we arrive at the Q&A part of the webinar. Give me a few seconds to go through the questions we had so far and try to answer them. So we had one question about the objectives of the competition. Is it equally weighted, or can we have different weights per stock? Let's just make that clear. Each stock has to be 2%. You have to allocate 2% across 50 stocks. There is no deviation from that rule. So you need to target 2% at each rebalancing date. So let's go back to my payout here. We could see I had some rebalancing dates. In this very instance, rebalancing dates are December, January, February, March. So it's only once a month I am rebalancing, and I am always allocating 2%. Okay, here 2%, 2%, 2%. So there is no deviation from that rule. It's only 2%. We have given you examples where weights could deviate, but that's just a generic thing that you could do in a general payout. But for this very competition, it's 2% per stock over 50 stock. So 2% times 50, you are allocated 100%. Obviously, in between each of these dates, the actual weights of your position, of your stock in your portfolio are going to move. They're going to move around. But don't worry about this. Just worry about when you do allocate, when you do rebalance, it's always 2%. Is there an R function to get the inclusion matrix? Yes, there is. Everything that we have available in Python is also available in R. And the beauty is that it is also the same function. So let's take a look at, here we go. I'd like to, here. If I want to start a new console in R, so from R, I'm going to wait for the kernel to launch. You can see maybe I could, the kernel has started. So in R you load the library with this, okay, so that's the equivalent of import Alphien, and then you are going to use directly the get tickers S&P 500 function. Let's take a subset so that we don't spend too much time loading that, but I'm just going to take the subset of the insurance, and then the difference is the name of the parameter, and that's as XTS to get this, and we're just going to let that run until it's executed. Maybe I could shut here. I'm going to shut that. Just always manage your kernels. That's just an advice in your lab. You see the number of kernels here. There are 3 kernels open. I don't need 3 kernels because I'm just using my notebook here and the console here. But that's the way it's going to run anyway. I invite you to obviously again take a look at this S&P 500. Each time you do that, you're gonna have the 2 versions. So that's why we have always 2 versions for things. Let me close this this. And here you can see the R version with the example, how to get the inclusion matrix. Yeah. You see the parameter is as XTS. That's the only difference between R and Python. Here, as an indicator matrix. That's it. Let's move on. I'll run that as we go. Yeah, so indeed, last webinar, as I said, some of the codes from the notebook were about getting that inclusion matrix to make things easier. And now, thanks to that function that we are actually looking at here, get tickers S&P, and the parameter in R, which is as XTS, in Python is called as price, you can get the inclusion matrix. So indeed, this notebook will be published, and you will see directly how to get the inclusion matrix. For example, in this payout, get the inclusion matrix. Here you see all the parameters that are used. Can I scroll right? Yeah. So here, as price equal true is the parameter that allows you to get the inclusion matrix. So yeah, basically you couldn't find the first notebook because we switched the notebook, we transformed it into an actual function so that it's easier for everyone. This one will be published by tonight. I'm having a question about what is the meaning of the returned data frame by the payout function, and that's good because we have one here. So let's just analyze this. So here you saw that the payout function, we called it with our data features, and it's returning a matrix. That's good. And it's returning a matrix of 107 rows by 667 columns. What is 667? Let's go back up. And our portfolio here, that's better. Let's take portfolio and let's look at the number of assets within the portfolio, and 667. So I have in my payout matrix, so basically my weight matrix. So the payout just returns the weights, okay, the matrix of weights in your portfolio. You correctly have 667 columns, which correspond to what I have in my portfolio. PF is my first portfolio I've created here. Where is it? Yeah, okay. It was using the same universe. Let's switch it to the correct portfolio here. Same stuff. I've included all tickers available. 667. So you have 667 assets. So you need to decide whether to allocate to them or not. Okay. And then, so that's for the columns. Each asset on the portfolio has one column. And as per the rows, there are dates. So you could see there are dates. Okay. There are dates, and at each date you can have a cross between a ticker and a date, and you know what the weight of your ticker, so of your stock in the portfolio at that date is. So this is what you buy. I want 2% of Apple. Here I want 2% of Apple again. Here I want 2% of Apple again. What happened between 29th of February and 31st of March is that Apple, the price of Apple, the stock, has drifted. So it went up, it went down. So in your portfolio, the weight of Apple was not constant because all prices, they go around. So obviously here, even if you had 2% that day, then it's going to drift away depending on the market performance of each stock. So it's going away. Here you're saying, I am rebalancing in March here. If let's say if the price of Apple and the relative weights of Apple in your portfolio went up, and now you ended up with, I don't know, 2.5% one month after this rebalancing here, then if you have 2.5%, you're going to say, oh, I want 2%, so I'm going to sell the extra 50 basis points of Apple that I have in my portfolio. And you're going to do that every month for every stock that you wanted. Okay, so that's really the meaning of that matrix. Is that's my target allocation. So this is what I'm going to target, either buy or sell to reach 2% on that day. And all the other ones, they get nothing. If there is a model associated with a strategy, do you expect the submitted files to retrain the model from scratch or to reload the model from path? That's a good question, and the best way is to have the model being able to be retrained. The reason is you might be willing in the future to retrain the model. So let's say your model is fit now, but maybe in 1 year it's not going to be fit. So we need to be able to replicate this, because your strategy is going to run into the future. It's going to be systematic, so it's going to be basically trading on new market data. So if you, for us to do that, we need to be able to replicate. That's one of the point here. If we go back to the knowledge base. When you submit your model, we need to be able to reproduce it. So if there is a model that you have trained and you have pre-trained, for you obviously it's better to use the model directly from path, because you don't want to retrain it every time you're testing your strategy. But we need to be able on our side to retrain it and to obtain the same model as you did on your personal space. For that, you need to, if there is a training, you need to either do it within the portfolio, within the payout function. So either you train it here, or what you can do is have many functions. For example, you would have here you have a def my training. My training loop. And then you would train it, okay? And then here inside the model you would call my training whenever you need it. This is quite important also to ensure that there is no data leakage, and that's why we ask you to provide us the function that allows you to train the model. We will obviously check that your model was not trained with data, for example, from 2015, and then you're investing in 2007. Doesn't make any sense. This is called forward bias, and it needs to be avoided absolutely. So this is also important for us to be able to check that. So always train the model only on the data that you have available to you. And I invite you to go on the wiki and read a bit more about that. If you go to the wiki and you look for a page called Preventing Lookahead Bias, this is a quite detailed explanation of what Lookahead bias is, and there are many advices that I suggest you read in order to help you see if you train a model, the model should be trained only with the blue data, never with the gray data, and when your predictions are reds. Okay, so we will check that. So we cannot trust a model that is being fed only from disk. It's not. Then we cannot verify if this has been respected. I think I have one more question, and we'll wrap it up. What is the rebalancing frequency for the equal weight benchmark at the moment here? Equal weight benchmark, because I'm using the inclusion matrix as it's returned. The inclusion matrix is returning daily inclusions. So this will be daily rebalancing. Obviously, in real life, you wouldn't daily rebalance, because otherwise transaction costs will make it very unsustainable and very costly to do so. But here, for the sake of this payout, it is daily rebalancing. So I think we wrap it up for today. Thank you everyone for participating. If you have follow-up questions, please do not hesitate to go on the forum or directly on the chat. We'll try to answer. It's also quite beneficial for everyone if you post the question on the forum, because it's helping others understand better also the constraints and how to do it. That's a good practice to start and use the forum. Also, please do not hesitate to answer questions on the forum or give your view or give your opinion, because we want to favor all sharing and cooperation. So if you know the answer and the quant team from Alphien didn't have time to reply to it, please do get involved. Please put the answer out, and that'll be beneficial for everyone. Thanks again, and hope to see you next week. We'll have another webinar and pretty good. So I hope to see you there. Thanks, and have a good day. Bye.